everyone, this is Mrs. Pettit, and I'm here to work with you through the second day of fractional exponents. We'll continue to work on fractional exponents that Mr. Sullivan started with you during your last class, but we'll also continue to work on negative exponents, powers, and roots that you worked on with several of the other math teachers. We'll be working on problems from this one document, but some I will leave for you, some I'll walk through with you, and some I'm going to put up in a different video with the exponent chart. When you're done, you can check all of your work against the answer key, or you can reach out to your teacher for clarification. So to start, I'll leave number 1 for you, and we'll look at number 2. To review the basics of what Mr. Sullivan taught you in your last class, if you have a fractional exponent, the numerator is the power and the denominator is the root index. So you can rewrite y to the 2/5 as the 5th root of y squared. But you also learned that it doesn't matter if you raise to the power and then take the root, or if you take the root and then raise to the power. So we could also write this as the 5th root of y and that entire quantity squared. Problem number 3 has a lot going on in that tiny little expression. First of all, the negative exponent tells us to send that to the denominator. So I will have 1 over t to the positive 3/4. But if I rewrite that in radical form, I'll have 1 over the 4th root of t cubed. But we also know that we never leave rads in the denominator, so we need to multiply by something that will give us a perfect 4th root, which means I need to multiply both the numerator and the denominator by the 4th root of t, which will give me the 4th root of t in the numerator and the 4th root of t to the 4th in the denominator, which leaves you with the 4th root of t over t. If we look at number 4, we want to rewrite in exponential form, but we don't want to have an exponent of 1.2. So we want to rewrite that as a fraction, so we can rewrite as y to the 12 over 10, and then simplify to y to the 6/5. We know that if we want to write a root in exponential form, we'll raise what's under the radical to a fractional exponent. And if there's no root index, it's implied to be a 2. So I can take everything that's under the radical and raise it to the 1/2 power. And then I have to raise everything within the parentheses to that power. So I'll have 7 to the 1/2 and x to the 3rd to the 1/2. And when we have a power to a power, we multiply, so we'll have 7 to the 1/2 and x to the 3/2. I'm going to skip 6 and 7 and look at number 8. If we want to write in exponential form, remember we want to write our root as a fractional exponent. But we also want to write our base as the smallest number possible. So I know that I can rewrite 36 as 6 squared. So the first thing I'm going to do is rewrite the 4th root of 36 as the 4th root of 6 squared. And then I'll write it as a fractional exponent, so I'll have 6 squared to the 1/4. And because I have a power to a power, I'll rewrite that by multiplying as 6 to the 2/4, which can simplify as 6 to the 1/2. At this point, I'm going to skip to number 19, 21, and 23 on the second page, but I will come back to number 13, 14, and 16 and do those with the exponent chart. I'll leave the others in between for you to try on your own and check against the answer key. But if we look at number 19, it doesn't matter whether we have whole number exponents or fractional exponents. The rule when we divide the same base to different powers is to keep the base and subtract the exponents. So this will become x to the 4/7 minus 2/3. To subtract 2/3 from 4/7, we need a common denominator, and the least common denominator between 7 and 3 is 21. So I'll multiply the left-hand side by 3/3 and the right-hand side by 7/7 and end up with x to the 12/21 minus 14/21, which is x to the -2/21. And the negative exponent tells us to change positions, so this will end up as 1/x to the 2/21. In number 21, I can lose the parentheses and just multiply everything together. So I can rewrite this as 2 times x to the 2/5 times 6 times x to the 1/4. And now I can just multiply the numbers. So 2 times 6 is 12. And when I multiply the variables to a power, the rule is if the base is the same, I add the exponents. So I'll have x to the 2/5 plus 1/4. And again, I'll need a common denominator, and the least common denominator between 5 and 4 is 20. So I'll multiply 2/5 by 4/4 and 1/4 by 5/5 and end up with 12 times x to the 8/20 plus 5/20. And when I combine those, I get 12 times x to the 13/20. And the last problem I want to look at on this page is number 23. Typically, I would move anything with a negative exponent to the opposite location, but because I can see that I'm then raising my power to a negative power, when I multiply a negative by a negative, some of those are going to become negative and some of them are going to become positive. So for now, I'm going to leave them where they are and raise the power to a power and then move any negative exponents to the opposite location when I'm done. So if I raise x to the 2/3 to the -12th and y to the -1/6 to the -12th, I have x to the -24/3, y to the 12/6, which simplifies down to x to the -8 y squared, and now the negative exponent is going to change location. So ultimately this will become y squared over x to the 8th. And the last problem I want to look at on this document before I move to the exponent chart video is problem number 26. Remember, just like always, work from the inside out. So start with the x raised to the -1/2 raised to the -6th power. And a power raised to a power means multiply. So -1/2 times -6 is +3. So this becomes x to the 3rd raised to the 1/3. And we still have a power to a power, so multiply again. And 3 times 1/3 is just 1. So our answer here is simply x. At this point, I'm going to start a new video with the exponent chart and look at problems number 13, 14, 16, and 29, and then leave the rest of the problems for you to try and check against the answer key.